Hi from Gabriele of Staticalmo, the statistical consulting service that aids your small, medium company or organization to make more rigorous decisions with various domains of statistics. Today I want to show you all an article and I will comment it. It deals with something that Italians don't know, that is NHL games that deal with hockey. The person wanted to predict the outcomes of the matches with statistics, so statistical models more or less advanced. And he did an admiring work in terms of data collection. He specifies that the base model forms a bit less than 50% and his best model performs slightly less than 58%. I want to remind you that the probability of tossing a coin and having one kind of result is 50%. But that result doesn't come from, for example, this kind of trials, but a limit of trials. The limit is a mathematical concept that you see in calculus, in high school and also in college or university. When you have not a limit of trials, you won't have 50% of probability, or head or tail, but something that wobbles around 50%. It can become 47, it can become 53. In my opinion, this is not as good as it looks. Most likely it is 53%. The person then specifies that in literature the best model performs this, and this is actually a significant result in my opinion, and another approach performs no more nor less than the result he had with a logistic regression. In this part he specifies all the data cleaning steps and all the data wrangling, and he did much of it, most likely more than my patience would handle. In this part he specifies the most fun part, in my opinion, that he divided the dataset in 70% train and 30% test. He did first a logistic regression, that is my approach, and then he did a more advanced model, that is a random forest, an evolution of the decision tree, then another kind of model, and the conclusion seemed a bit pessimistic. He had a result not so thrilling, even though he built the model with a rolling statistic time frame of 15, 25 and 40 games. I generally don't agree with the rolling models because it is very difficult to establish which kind of time frame you have to create. You can do it in an algorithmic way, but it is not the way he established this. So this doesn't look so good, and for this reason he concludes that it's difficult to predict game outcomes with statistics. And I would add that of course it is difficult if you proceed like he did, and let's understand why jumping into the code. First of all, in the EDA, that means exploratory data analysis, he didn't do exploratory data analysis but something else, that means data wrangling mainly, and I don't understand then why he gave it this kind of label. Let's go in the part where the meat is on the BBQ, and again here you see some data operation, again the boring part. Here it starts with the rolling time frames. Here it starts with the rolling columns, more data wrangling, again more data wrangling, and here the final data set. Logistic regression. Here you see a mistake that I commented in many occasions. The usual computer scientist approach to statistical modeling is to fill the model with all the features, in this case the columns. Fortunately, let's say he didn't put all the columns, but all the columns he created. And this is not a best practice. You have to check which variables to put in the model. How? Running correlations. You pick the significant one and you have some candidates to put into the model. Generally, I also do the Bayesian correlation, but you can check this in my other videos. Then it surprised me that he didn't do the cross-validation, and generally computer scientists do it. What does it mean? That you train the model with different chunks of the dataset. In this way, at the end, you don't have just 1 point for accuracy, you have a range for accuracy. The shorter the range, the more stable is your model. We can say that doing the cross-validation is somewhat similar to the chart I often show about Bayesian correlation, because you see how the significance for a variable changes across time. In this case, you can see how the model performs across time. If you have a stable model, most likely the variables you choose are stable as well in terms of significance. So as you can see, sometimes computer scientists and statisticians have different tools for somewhat answering the same question. Again, I feel surprised that he didn't put the cross-validation, and mind that in the library of Python he used, we have this kind of function. So it really surprises me that he didn't put this kind of check. Then we have the confusion matrix in a textual way and then in a graphical way. Then we have the accuracy he mentioned in the article. Then he did the chart for the area under the curve, and surprisingly he didn't put a chart also for the ROC, that is a kind of diagnostic for the logistic model, so basically with all the classification models. Again, I see this as a mistake. This is the third mistake so far. Fourth mistake is he didn't plot the histogram of the predictions. The logistic models returns probabilities. From the probabilities, by default, it says if the probability is higher or equal of 50%, then the label becomes 1, otherwise 0. We need this kind of chart because with it we can do the optimal number for the threshold. Maybe 0.5 or 50% won't yield the best result. Fourth mistake, so this is another mistake. He goes on with a random forest, and here, again with my surprise, because computer scientists generally don't do it, he put fixed values for the tuning of the model. You can think of tuning of the model like ECU for the car. Generally, computer scientists, but also statisticians, do it in an algorithmic way, and then they pick the values that yield the best outcome in terms of the metrics you choose. The person doesn't do it. In the article, they just specify what I said. Using the grid search will yield better results. So I find this the fifth mistake. And he did. I mind that the random forest doesn't significantly perform more or less than the logistic model. Then he does another kind of model. Again, you see the result is stuck to the one of 57%. My conclusions will look similar to the one of other videos, but with an entirely different context, the sanitary one. You can't do a statistical model with just internal variables. In the case of the sanitary ones, we didn't have external variables like the lifestyle of the patient. In this case, we don't have more details, for example, on the composition of the team that played on that day, or maybe the day of the week they played or the month. Maybe some teams have a seasonal component, given also by fatigue. This video has also common points with the financial videos I made. We have too few useful columns. Also, it didn't check for the significance of the correlations. So, as you can see, it is not enough to do heavy data scraping, as he did with Selenium, as he did also here. And it is not also enough to do the heavy works in terms of data wrangling. And it is not enough also to be able to do some statistical models like the logistic regression and so on. It is not enough to do what he did to have satisfying results in this context. If you wish to avoid a computer scientist approach with 5 mistakes, you know who to call. I salute you. See you the next time.